Okay, class 10, it's 119, right? Uh, Good afternoon, everybody. Good afternoon. So, everybody is present today? And do you know today's date? What is today's date? 19th of Jester 2077. Yeah. So, we are discussing the chapter pressure, right? And what did we discuss yesterday? Could you remember? We discussed some numerical problems where we use the formula ratio of areas equals to ratio of forces, F2 by F1 equals to A2 by A1. And then we discussed about some machines which work on the basis of Pascal's law: hydraulic garage lift and hydraulic brakes. So what are we going to discuss today? I have already shared the screen. So who is going to say that matter? What are we going to discuss today? Do you know? Who can say? So they are not speaking. We are speaking about one new principle. What is that principle? Do you know? The principle is Archimedes Principle. What is that? Archimedes Principle. But before discussion of Archimedes Principle, here is one new heading. Can you see in your screen what is there? Upthrust. So first of all, we will be discussing about upthrust. What is upthrust? Who can say about upthrust? Students, let's do one minor experiment. Take a bucket and just place that bucket inside the well. In well, definitely there is water. Suppose the bucket is full of water, you start pulling it. You can pull it till it is inside water in the well. Again, if we apply more force, it comes little bit higher position. Now question arises, when do we feel more difficult or more difficulty? When the bucket is inside the water or outside the water? Definitely inside the water. Students, you might have noticed, you may go for swimming, right? And when you are inside the water, you feel lighter. But when you come outside, you feel quite heavier. Why do you feel lighter when you are inside the water? What's the reason? The main reason is, if any object is kept in a liquid, at that time, the liquid pushes the object with some force. That force makes us lighter inside water. Not only for us, any object, when it is immersed, when it is kept inside liquid wholly or partially, at that time, it experiences some upward force. That upward force is called upthrust. Because of upthrust, the body feels lighter. Body feels lighter. Okay, students, now let's give the definition of upthrust. What does upthrust mean? Here is the definition. When a body is wholly or partially immersed in a fluid. Fluid means whether liquid or gas, the resultant force acted on it by the fluid is called upthrust or buoyant force. The other name of upthrust is buoyant force. Here you just keep in mind, a body is kept in a fluid, either liquid or gas. The liquid or gas pushes the body with some force. That force acts always upward in above condition or position, that is called upthrust or buoyant force. Students, now look at here. I'm going to explain something. What is that? Here is given one experiment. Can you see it? Measurement of upthrust is given. So please look at here the diagram. In any activity, we need some materials. So materials required: spring balance, overflow can, beaker, stone, string and water. So this is spring balance, and here is stone. This is beaker. This is overflow can, and this one is beaker. Okay. So why is spring balance used? Spring balance is used to measure the weight. Understood or not? An overflow can to let the water to be displaced. Overflow means when the amount of liquid or the level of liquid rises up, at that time it goes out automatically. So overflow can, and here is beaker. Okay students, what does the experiment say? Take a stone tied in a spring balance. Take a stone tied in a string and suspend it from a spring balance as shown in the given diagram. So just check it here. So let me rub out this so that it will be quite easy for you. First we need one stone, and that stone must be tied here with the help of a string, and it must be connected to the spring balance. So spring balance shows some weight. That weight is written as W1. W1 means weight of the body in air. Weight of the body in air. Then here is another device. What is name? Overflow can. What is name? Overflow can. So the liquid is kept up to this spout. So when some more liquid comes, or when the level of liquid rises up, then automatically it comes out. Okay, the liquid comes out, and the liquid which comes out is collected in another device, that is beaker. So here is beaker. So let me show you the beaker here. The water which comes out from the spout, this is called spout, is collected in this beaker. Okay, suppose, actually exactly we cannot say. Suppose the weight of the body in air is 50 Newton, and when it is immersed in water, its weight is how much Newton? 20 Newton. Suppose 20 Newton. At that time, some mass is lost, isn't it? Its not mass, its weight is lost when it was in air, when it was measured in air, 50 Newton. When immersed in water and measured, it becomes 20 Newton, means some weight is disappeared. Where has it gone? It is disappeared, it is decreased because of upward push of the liquid. And that difference, weight in air minus weight in liquid is of thrust. And again, student, if we measure the water which is collected in beaker, will be also equal to the difference, means 30 Newton. So here 30 Newton is the of thrust. Next thing, let me tell you, if my weight is 500 Newton in air, what is my weight? 500 Newton. And when I go for swimming, my weight will increase or decrease? Obviously it decreases. And how much weight it decreases? So that is the upthrust applied by liquid to me. For example, if my weight is 500 Newton and if I weigh 300 Newton in water, at that time what is the difference? 500 Newton minus 200 Newton. Sorry, 300 Newton equals to 200 Newton is the upthrust applied by water for my body. I experience how much upthrust? 200 Newton. And how much weight of water do I displace? I displace 200 Newton of water. How much my weight decreases, that much water is displaced. So here you have to remember, upthrust is equal to weight of water displaced. So here is given one formula, please check it here. Apparent weight means weight in liquid. Weight in air is real weight. And apparent weight means weight in liquid, weight in fluid. So apparent weight equals to weight in real weight or weight in air minus upthrust. So always keep in mind, if any object is immersed in a liquid or a gas, at that time some of its weight is lost. That weight is lost due to upthrust of the fluid. Upthrust of the fluid. Okay students, now we are going to discuss new headings. What are they? Density and relative density. Okay. Students, now listen. There is one sack full of cotton and one sack full of rice. Okay. One sack full of cotton and one sack full of rice. So which one will be easier to carry?
The time now is 13:30.
Which one will be easier to carry? Rice or iron? Definitely it is easier to carry rice. And if there is one sack full of cotton and one sack full of rice, which one will be easier to carry? Definitely it will be easier to carry the cotton. So here we have to keep in mind the ratio of mass and volume of substance differs from one to another. So that ratio of mass and volume is called density. We call it density. Actually, the density of cotton is less than density of rice. That's why we feel easier to carry cotton and difficult to carry rice, isn't it? So how to define density? What is the definition of density? Mass per unit volume of a substance is called density. Mass per unit volume of a substance is called density. Formula is there, D equals to m by v. D equals to m by v. What is D? Density. M, mass. V, volume. Okay. So SI unit of density is kg cubic meter, kg m/m cube, and in CGS system it is gram per cc. In SI kg/m cube, in CGS gram per cc or cm cube also can be written, okay, cm cube. So here is one relation between kg per meter cube and gram per cm cube. So what is the relation? 1000 kg per m cube equals to 1 gram per cm cube. 1000 kg equals meter per cube. So 1000 kg per meter cube equals to 1 gram per cm cube. If there is 2000 kg per meter cube, then it will be 2 gram per cm cube. And next thing, density of a substance is always constant. Density of substance is always constant. It does not differ from place to place. Dear students, now let's discuss the density of some substances. It's given here one table. So what about the density of gold? Density of gold is 19,300 kg per meter cube or 19.3 gram per cm cube. Mercury 13,600 kg per meter cube or cubic meter, and or we can write in CGS 13.6. Lead 11,000 kg per meter cube. In CGS 11 gram per cm cube. Iron 8,008. Common salt 2,170, 2.17. Aluminium 2,700, 2.7. Sugar 1590, 1.59. Pure milk 1030, 1.03. It means if it is given 19.3, it means it is 19.3 times heavier than water. Lead 11 times heavier than water. So we can compare like this. So let me rub out this once. We are discussing the density chart, and this density chart shows the heaviest substance is gold according to this chart, and we will be discussing the lightest what is there. Pure milk is also heavier than water. And what is the SI unit, means density of water? Density of water is 1000 kg per meter cube or 1 gram per cc. Ice 920, 0.92 means, now here you have to keep in mind, ice is lighter than water. That's why ice floats on water. Iron is heavier than water. That's why it sinks in water. Density of wood is 600 to 800, differs from one to another, 0.6 to 0.8. And kerosene 800 kg per meter cube or 0.8. Here we have to keep in mind, kerosene also floats in water. If density of a substance is more than 1, it sinks in water. If density of substance is less than 1, then it floats. Alright? It floats. Students, now listen. Tell me, at which temperature the density of water maximum? At 0 degree centigrade, or at 50 degree centigrade, or at 10 degree centigrade, or at 4 degree centigrade? We know if the substance is in solid state, its density is, means it is a heavier one. If it is in liquid state or gaseous state, it is a bit lighter. But here we have to keep in mind, solid of water is lighter than liquid. It means water at 4 degrees centigrade is heavier than water at other temperatures. It means water has highest density at 4 degrees centigrade. At 4 degrees centigrade, the molecules of water are very much tightly packed. That's why more mass is present in less volume. Okay, remember here. So students, if we compare the density of any substance to density of water at 4 degrees centigrade, then we call it relative density. What did I say? If we compare density of any substance with density of pure water at 4 degrees centigrade, we call it relative density. So in the relation. So how to define relative density? One formula is given here. Please check it here. Relative density means ratio of density of substance to density of pure water at 4 degrees centigrade. Relative density is defined as density of a substance by density of pure water at 4 degrees centigrade. Simply remember, relative density is that ratio in which one component is density of the substance, next component is density of pure water at 4 degrees centigrade. Students, so relative density is the ratio of two similar quantities. That's why it has no unit. It has no unit. And I said earlier, if relative density is 2.5, it means it is 2.5 times heavier than water. 2.5 times heavier than water. Alright? Okay, students. So we know the SI unit of density is kg per meter cube. And in CGS unit, it is gram per cm cube. But relative density has no unit because it is the ratio of similar units. Dear students, in class 9, we have studied about mechanical advantage, velocity ratio. So those substances also don't have any units because they are the ratio of similar fundamental or physical quantities. Now students, we are discussing one next heading. What is that? Interrelationship between density and upthrust. Interrelationship between density and upthrust. Do you know an egg sinks in salty water and floats on pure water? Or it will be easier for us to swim in ocean and difficult in pond water. Why? What's the reason? Yeah, the reason is due to presence of salt. That's right. Due to presence of salt means when salt is added, the density of water increases. Okay? When density of water increases, then its pushing, upward pushing force also increases. More density, more pushing force. Less density, less pushing force. That's why it is very easy for us to swim in seawater, difficulty in pond water due to density of water. In the same way, here are two beakers. Please check them. In first beaker, what is kept? Pure water. In second beaker, what is kept? Salt solution. In water, some amount of salt is added and made a solution. In each beaker, what is kept? Egg is kept. So the egg is sinking in pure water. The egg is floating in pure water. Why? Because the density of pure water is less, so egg sinks. The density of salty water is more, that's why it floats. Dear students, floating and sinking depends upon density of liquid. So you might have gone for swimming. In swimming pool, you have seen the color of water. What is the color? Blue color. Why? Because salt is added there. They add some salt. Especially they use copper sulfate so that it is quite easier for us to swim. But in pond water, nothing is kept. It will be difficult for us to swim because we get less pushing force from the liquid. In swimming pool, we get more pushing force, that is upthrust or buoyant force. Here is given something. A cargo loaded ship floats more in ocean than in river. Why? Because in ocean, the water has more density, so it experiences more upthrust or upward pushing force. But in rivers, the density of water is less, so it does not float easily. Okay? So this floating, sinking depends upon upthrust. And floating, sinking depends upon density of liquid also. Density of liquid. Students, just you tell me, suppose there is a swimming pool of honey. Oh my God, swimming pool of honey. One is swimming pool of honey. Next is swimming pool of water. So where will we experience more upthrust? In honey or in water? Definitely in honey, because its density is more. Okay? And you know mercury, the density of mercury is 13.6, it was shown. So where will it be easier for us to swim? In water or in mercury? Definitely in mercury. In mercury, we may not sink also, because it applies us more upthrust. More density, more upthrust. So students, what can we say? Density of a substance is directly proportional to upthrust. Density is directly proportional to upthrust. Please note it down. Now students, finally we are discussing one next principle. I said earlier, in this chapter we are discussing mainly three principles, three laws. One, Pascal's law, another is Archimedes Principle, and next one is law of flotation or principle of flotation. Pascal's law propounded by Blaise Pascal, and Archimedes Principle was propounded by Greek scientist Archimedes near about 2300 years ago. It was propounded 2300 years ago, but still it is applicable. How talented he was, right? So he performed experiment and propounded one law, and it is called Archimedes Principle. Here is given Archimedes Principle. What does it say? When a body is partially or wholly immersed in liquid. Either some part only or whole part is kept inside the liquid. It experiences an upthrust which is equal to the weight of the liquid displaced by it. Archimedes says simple things, but long-lasting thing. Simple but long-lasting. What is that? If any object is kept in a liquid, either completely inside or partially, some part only, at that time it experiences upward force. That upward force is equal to the liquid displaced by it. How much liquid it displaces, that much upward force is experienced. So from Archimedes principle, we have got one formula. What is the formula? Upthrust equals to weight of displaced liquid. Earlier we have done one formula. Upthrust equals to weight of the body in air minus weight of the body in liquid. Here upthrust equals to weight of the displaced liquid. Very simple formula he has given. So if one question is asked to you, suppose Ram weighs 90 Newton in air. Ram weighs 90 Newton in air and 50 Newton in water. How much upthrust is experienced by him? What is the difference? 40 Newton upthrust is experienced by him. That is the one. And how much liquid does he displace? He displaces 40 Newton. Upthrust and weight of displaced liquid are always equal. So remember these things. Okay students, one formula now we are going to derive from Archimedes principle, that is U equals to, remember U equals to V d G. U, what is the full form of U? Or what does U mean? Upthrust. What is V? Volume immersed. What is D? Density of liquid. What is G? Acceleration due to gravity. Students, a similar one formula we have derived last time. Could you remember? That formula was P d G. Liquid pressure equals to H d G. Upthrust equals to V d G. See, this type of formula to be practiced and stated in mind. And I want to request you, this is the derivation that you are doing for the first time. That's why you have to practice 3 times. And which you have practiced earlier, you have to do 1 time. Okay students, suppose now we are going to derive one formula. What is that? U equals to VdG. Suppose here is one container. Here is one container, and in the container liquid is kept. What is here? Liquid. Then one object is kept inside it. This is the object. When any object is kept inside it, it experiences liquid pressure. See, from up, from side, from down. What is applied? Pressure. See? And not only pressure, it is okay. So time has gone, students. Again, you come here. Now, this is of how much minutes? Let me see. Start meeting is here. This Zoom. In case of Zoom, after 40 minutes, automatically it goes and we have to connect it. We are discussing the things that are connected to The chapter. Which chapter? Pressure. Okay, so let me make it here. Schedule we have to do, then only it comes. Okay, done. They are just joining. Alright students, so I'm just joining again. So Zoom is like this. Actually sometimes what happens, it gives different. Yeah, it has come. Good, one has come. Students are coming. They are coming. Okay, 1 2. So if they come, then it will be quite easy. So I'm just going to complete this derivation of v u equals to v dg. Let them come. So please don't make noise. Someone is coming. I am just accepting them. So be prepared for a derivation of the formula v u equals to v dg. It's coming. Okay, so now let me share the screen. I'll share the screen and then make you to do up to date. Okay, what is here? So it's the time to share the screen. So just one diagram I was just going to explain. Document, then what is here? Device storage, then cam scanner, then class 10. Today is Tuesday. Class 10 Monday. Share it. Okay, students, it's coming now. Please wait a minute. Now we don't have more work to discuss today. Of thrust we discussed density and relative density also. Now I'm going to make you to do this derivation, that is to, okay students, look at here. Archimedes principle, we discussed that if any object is kept in a liquid partially or wholly, then it experiences upthrust, that is equal to weight of displaced liquid, and we are going to derive the formula u equals to v dg. So look at here, one device is here. In device, what is kept? One rectangular object is kept. So if the object is placed inside the liquid, it experiences liquid pressure from all direction. From all direction, it is shown by this arrow like this. See, it experiences from here also, it gets pressure from here. It gets pressure means force also it experiences. And suppose density of the liquid be d. Density of the liquid is d, and cross sectional area of the device is a. And here is given, see, this is up to down. This is h1, and from base to top is h2, and this middle portion is h, height of the object. Suppose the force applied in upper side is P1 multiplied by A. Force acted on upper surface is P1 multiplied by A, that is, to remember, F1 equals to P1 times A. What is P1? Liquid pressure at upper side, because liquid pressure differs from the height. When the height differs, liquid pressure also differs. Now students, P1 equals to, you have done F1 equals to P1 times A, then we know P equals to H dg. So what is written here? F1 equals to dg h1. Why h1? First height, and A is already there. So again, in the same way, F2 equals to P2A, and P2 means dg h2. P means HDG, but P2 means second pressure, second height. H1, first height. So here is F1, upper place, we can see F1 equals to dg h1a, F2 equals to dg h2a. So if we subtract F1 from F2, then what do you get? Upward force. Then here is given F2 by F2 minus F1 equals to dg h2a minus dg h1a. Now F2 minus F1 is upward force, that is upward force, equals to what is common here in between these two? dg h2a, dg h1a means dga, and what is left? h2 minus h1. Now h2 minus h1 is h, so it becomes d g a h. So if you multiply a and h, then what do you get? Volume. So dgv. So formula of U equals to dgv. What is g? Acceleration due to gravity. What is v? Volume immersed. And what is d? Density of liquid. So formula of U is dgv. dgv. And what is the relation? U is directly proportional to v. U is directly proportional to v. U is directly proportional to d. U is directly proportional to g. These are the things. So in this way we can show upthrust is equal to density of liquid, acceleration due to gravity, volume immersed. And if we multiply d and v, it comes m, upthrust equals to mg. See, mg means weight of the body, isn't it? Archimedes principle also says same thing. So remember this formula, U equals to v dg. Dear students, now finally let's recap today's matter. What was discussed? We started from upthrust, and then we discussed calculation of upthrust. Upthrust is equal to weight of the body minus
The time now is
in air
14 o'clock.
weight of the body in liquid. And we discuss about density and relative density. Density has unit, but relative density has no unit. Density of a substance is always constant. So CGS unit is 1000 times. What is the relation between CGS unit and SI unit? 1000 kg per meter cube equals to 1 gram per cm cube. And we showed the relation between density and upthrust. They are directly proportional to each other. And next, Archimedes principle states that when a body is wholly or partially immersed in a liquid, it experiences upthrust. Obviously, that upthrust is equal to weight of displaced liquid. And we found another formula here, that is U equals to V dg. U equals to V dg. What is V? V is volume immersed. Next, D is density of liquid, and G is acceleration due to gravity. Okay students, now let me check your position, what are you doing, whether they are listening carefully or not. Everybody make your video on. Please make your video on. Ashok, good. Did you write something, Ashok, today? Did you write something or not?
Yes, sir.
Good. And Galaxy J4 Plus, who is this? Vivek Saha. Please make your video on, then I can find out my students are attentive and studying well. Sujal, Ojas, and where are others?
Yes, sir.
Yeah. Okay. Ashok is there. Sujal is there. Oh, good. And did you write something or not? Did you write? And I told you to make note and submit to me. Why aren't you submitting the note to me? I found Vivek is submitting. Vivek is submitting on time, I know. And he is being everyday alpha student. Now I want to see all other students also as alpha student, okay? So what's the time now? It's 14:05. By 3 o'clock, who is able to show me the first one? That is the champion student. Today, this much?
Excuse, sir.
Yeah.
Yes, sir.
Yeah, who is asking question? Who is there?
Yes, sir.
Yeah, please tell me. Ashok is asking
My
question.
note already submitted.
Sorry, your note already submitted?
Yes, sir.
Very good, very good. So I will check it and I will make you alpha student. Those who submit on time, they are alpha. And rest others also must be alpha student. There should not be any beta, theta, gamma students. Okay? Okay. Thank you very much. Bye-bye. Have a nice day.
Okay, sir.
Bye-bye.